Hello students, welcome to my YouTube channel. I am Arundam sir, teaching physics for almost 20 years. I have dedicated this channel to all the students who love physics, and this is free of cost. If you like this video, please press the like button and subscribe my channel to get the new videos. Today we are going to continue motion in 1D. In our last class, we studied different types of graphs regarding displacement time graphs. Today, we will study different types of different graphs, different V versus T graphs. Okay, so today we will study different V versus T graphs. Number 1. The x-axis is t-axis and the y-axis is v-axis. The graph is like this. The graph is parallel to x-axis. So in this case, theta equals to 0 degree. So tan theta, and tan theta equals to acceleration. V by t equals del v by del t equals to 0. So acceleration is 0. So acceleration is 0 when the graph is parallel to x-axis, that means time axis. The acceleration is 0. It means the body moves with constant velocity. The body moves with constant velocity. Second graph. Here the graph is parallel to y-axis. So theta equals to 90 degree here. So acceleration equals to del v by del t equals to tan theta equals to tan 90 degree equals to infinity. So the particle possesses infinite acceleration. So the particle possesses infinite acceleration. Practically this is not possible. Practically this is not possible. So in practical we never see this type of motion where the acceleration is infinite. Number 3 graph. The graph is like this. So here theta equals to constant. Theta is not changing. The graph is a straight line graph. So theta is constant. So acceleration equals to tan theta equal to constant. So acceleration is not changing here. So the body moves with constant acceleration. The body moves with constant acceleration. Graph number 4. Here we see theta is continuously increasing. And what is theta? Always keep in mind that theta is the tangent at any point. Theta is the angle that the tangent at any point on the graph makes with x-axis. So theta is the angle that the tangent at any point on the graph makes with x-axis. So here theta is continuously increasing. It is continuously increasing. So acceleration equals to tan theta is also increasing, because we know the value of tangent increases with the angle. If angle increases, the value of tangent also increases. Graph number 5. Theta here, theta is continuously decreasing. Theta is continuously decreasing. So acceleration equals to tan theta is also decreasing. Is also decreasing. Graph number 6. Here we see that theta is constant and less than 90 degrees. Theta is constant and less than 90 degrees. So the angle that the graph makes with x-axis, or the graph is linear here, and the graph makes an angle theta with the x-axis, and it is less than 90 degree here. So initial velocity of the particle is negative, and another thing we have to see that this is called initial velocity u. U is less than 0, u is negative. Initial velocity is negative, and it is moving with constant acceleration. Moving with constant acceleration. Initial velocity is negative, this is positive v-axis and this is negative v-axis. So the starting point is on the negative side of v. So the initial velocity is negative and the acceleration is constant. It is moving with constant acceleration. Graph number 7. This is like this. This is T, this is V, and the graph is like this. So we see that the theta is constant. Theta is constant. Initial velocity, this is u greater than 0. U is positive here. U greater than 0. So the initial velocity is positive and the body moves with constant acceleration. Graph number 8. Graph number 8. So here we see u positive, but a theta is greater than 90 degree. So a equals to tan theta less than 0, because we know that for the angle greater than 90 degree tangent becomes negative. So acceleration is negative and u is positive. U is positive. So the body initial velocity. So the initial velocity of the body is positive and it moves with negative acceleration, that is retardation. So negative acceleration means retardation. So the body moves with retardation. This indicates that the body moves with retardation. Here we write some equations of motion. Number 1, v equals to u plus at. Number 2, s equals to ut plus half at square. Number 3, v square equals to u square plus twice as. Number 4, STF. STF means the distance covered in time, th second. The distance covered in th second. Distance covered in th second. Th second means, suppose a body travels for 10 seconds. If anybody asks what is the distance covered by the body in 5th second, it means 5th second. Just look at this. This is the distance covered in 1st second. This is suppose it is moving with constant acceleration, so the distance is increasing. This is 3rd second. This is 4th second. This is the distance covered in 5th second, 6th second, and like this. Okay, so this is the distance covered in 5th second. And what do we get here? the distance covered in 5 seconds means the distance covered in 5 seconds minus the distance covered in 4 seconds. So S5 is 4, not 5th, not 4th. S5 means distance covered in 5 seconds. S4 means distance covered in 4 seconds, and this distance is called S5th. So distance covered in 5th second is given by the equation distance covered by in tth second equals to u plus half a t minus 1, where t indicates the th second. So if anybody asks what is the distance covered by the body in 5th second, you have to put t equals to 5 in this equation. Okay. You are all you know all these equations, especially 1, 2, 3. Number 4 may be new to you. 1, 2, 3 are very common equations you have studied in class 9 and 10. We can derive the equations of motion by calculus. The derivation of equations of motion by calculus method. So at first we write E equals to dV, implies dV equals to a dt. Now if we integrate for time t equal to 0 to t equals to t, we can substitute the value of v at 0 is u and at t is v. V is the final velocity, so the integral limit becomes u to v and 0 to t here. Okay, for time t equals to 0, regarding velocity is u. For time t equals to t, regarding velocity is v, because final velocity is v. So we know the integration of dv is v, so v into v, and acceleration constant, it comes outside, and the integration of t is t, so 0 to t implies v minus u equals to a t minus 0. We put the upper limits and lower limits here and then subtract those values. So upper limit is v, we put v instead of v and put u instead of v, and then we subtract. Here the same thing happens, we put upper limit and then the lower limit and then subtract it. So v minus a equals to at implies v equals to u plus at. Proved. Very simple. So with the help of calculus, we can prove the equation 1. V equals to u plus at. Similarly, we can prove s equals to ut plus half at this, just like this. V equals to ds dt. So ds equals to v dt. Now we put the limits v dt for t equal to 0 to t, and we know that initial velocity is initial displacement is 0 for time equal to 0 say, and then we write final displacement s for time t equals to t. So it becomes s 0 to s v t. We cannot take v outside because v is dependent on t, so we have to put the values of v here. So 0 to s ds 0 to t, and put the value of v. What is v? V equals to u plus at. We have derived it earlier. So it becomes integration 0 to s ds integration 0 to t u dt plus integration 0 to t at dt. So it becomes s integration 0 to s u t integration upper limit lower limit 0 t t and 0 a integration of t is t square by 2. Upper limit is t and lower limit is 0. So it is s minus 0 equals to u t minus 0 plus a t square by 2 minus 0 square by 2. So it becomes s equals to ut plus half at square. The third equation is u square equals to u square plus 2as. So it begins from this a equals to dv dt. Then we write dv by ds dot ds by dt. So these get cancelled, and this is we can just include ds here because the equation includes s, v and t. So not v and t, but it includes also a. So we have to include s here. That is why we have divided dv by ds, then multiplied the whole thing by ds. So ds get cancelled. Now ds by dt becomes v. So v dv ds, right? So after cross multiplication we get a ds equals to v dv. So integration 0 to a is a ds. So when distance is 0, initial velocity is 0. When the distance is initial velocity is u. When the distance is s, final velocity is v. So we write this. So a integration a constant comes outside. A integration of ds is s 0 to s. Integration of v is v square by 2. So upper limit is v and lower limit is u. So ultimately it becomes s minus 0, and this is v square by 2 minus u square by 2. S equal to v square minus u square by 2 implies v square minus u square equal to twice s, and this gives v square equal to u square plus 2s. So we derive all these three equations. These are very easy. You have to practice it 2 or 3 times, then you can easily get a grip on it. Okay. In our next class we will do numericals on motion in 1D. If you like this video, then please subscribe my channel and press the like button. Please subscribe my channel. If you subscribe my channel, then you will get the latest updates and all the videos regarding class 11 and class 12. Okay, please subscribe my channel. I am requesting you, please subscribe my channel. Thank you.